Hello, Ben.
Hello, John. It's been a while.
Has it? I don't know what you're talking about. I'm sitting here. It's April 21st, 2023. Rust 169 just came out. I feel like it's barely been any time since last time we recorded.
I know what happened. You traveled to Europe and you went all the way around the galaxy. So you went at the speed of light or faster even. And so because of relativity, etc., Einstein and so on, as far as you're concerned, it's actually like 6 months ago. But in the future, here where we are right now, there are in fact like 20 more Rust releases that we have not yet covered, but we're on it. We're doing it.
It's true. We are on it.
We got a backlog. We've got a shovel.
And to be clear, I just want to clarify something you said. You said travel at the speed of light. I think what you meant is travel at the speed of Rust.
Mm-hmm, mm-hmm. Well, as we know, in physics, when they want to indicate something very fast, they use the letter Rust to indicate
that's right.
the
letter
fastest
Rust.
possible thing.
Exactly
so,
right.
Yeah.
Well, given that I'm back in time, I'm planning to cover the previous two releases. So we're going to start with Rust 168. You good with that?
That's you know what? That sounds fine by me. I think those are fine releases that really need their just desserts.
It's true. All right, let's dive right in. So the first headline feature for Rust 168 is Cargo's sparse protocol. Now, if you're in the future, like Ben is, you might have heard more about this in later releases. And so we won't spoil you with that head. We'll start by talking about what's actually in 168. Now, this is a feature that I had a little bit of a hand in, and so therefore I'm not going to be the one to talk about it, because I'll dive too far down a rabbit hole.
It would be a conflict of interest, frankly.
That's really, exactly right.
I think I, as someone who doesn't know a dang thing about anything, should talk about this. So anyway, this is one of the things that where the sparse protocol, where you really don't need to worry about it, and in future releases, especially so. But it's one of those nice quality of life things. It kind of just shows how far Rust has come from the beginning. And so let's talk about what a registry is in the case of Cargo, right? So whenever you have a cargo.toml and you type regex equals 1.0 or whatever to actually get a library, what happens there? It's not just like getting
magic.
It's magic, obviously, but it's not just going to crates.io and getting the exact 1.0 version of regex, because trying to balance what versions to actually get is a complex question that has many solutions, and Cargo has one such solution. In particular, Cargo is trying to minimize the number of copies of a library that you have to compile and then wait to be compiled or to download the code for. But also, having more than one copy of a library in your binary is possible, but sometimes undesirable, where if you have the same type exposed from two different versions of the same library, they aren't compatible. And so if any given two libraries both expose either taking or receiving types from some third library, if those two libraries aren't using the exact same version of the library, then that's a problem. And so Cargo, first of all, it has a resolver, a version resolver, where it looks through your entire dependency tree and tries to find essentially a happy medium between compatibility and speed, and compatibility more than one way. But anyway, the point of this is that when you type regex equals 1.0, you're not just getting 1.0, you're getting by default some version that is compatible with 1.0 in your final binary. And what version you actually get will depend on everything else that you depend on. But to actually compute that requires an index. And so the index is nothing more than a list of all the libraries that every library on crates.io depends on. And it uses it's basically one big, huge data structure. And Cargo uses this data structure to figure out your actual, essentially the cargo.lock file. So to figure out the versions that will go in that lock file. And when it does this, to get this index, right, historically, when Cargo was young, was but a baby, the simplest thing possible was, hey, we have this sort of like text-based data structure thing going on here, and we're already using Git. Let's just throw it up in a Git repo and not worry about it, and let GitHub handle the hosting for it, which was a totally reasonable proposition back in 2014, right? When the Rust project had many fewer dollars to spend and was moving very fast towards 1.0 and wanted anything that worked at all. And in the meantime, Rust has grown very large. I don't know if you've been to Chris.io recently, but there's let's pull up the live number here, 125,000 crates, and they all have probably, the average version for any given crate is probably at least 10, I'm going to assume. Many only have one, but lots have like 1,000.
Yep. Yep.
When you consider all the point releases, all the minor releases, and all these things. So to try to encapsulate this data structure, and by storing it in a text file in a one giant blob as kind of a TRIE, a trie, as we would say in France.
Definitely trie.
It eventually became too much for GitHub, and they kind of requested that, hey, Rust, please don't do this. It's a bit more complicated than that, but GitHub definitely did at some point request that Rust change up strategy in various ways, and there has been some development in the past few years in terms of like not putting too much undue pressure on GitHub's infrastructure.
Well, and to be clear, it's not even just pressure from GitHub. It's also like, as a user, you probably experience this.
Right. And so, so it's not so as a user, most of the time to get the index, because again, it's using Git. And so if you ever cloned a Git repo, the first clone is really big, and then the rest of the time it just you get a delta of your repo, and it's not as long. But especially for things like CI, if you have a CI job that's compiling your Rust code, and you have to get the entire index every single time that you spin up a new CI job, that's a huge bottleneck for any sort of like Rust CI stuff. And so the new fancy way that Jon has so graciously implemented for us. Did you design it as well, or just like implemented it?
Well, I want to be careful about not taking too much credit here. So I did not write the original RFC for this. I helped out with the RFC, and then I implemented basically a prototype implementation in Cargo, showing that it is faster than all of the Git in basically all of the cases. And then Arlo, who currently works at Microsoft, I believe, did a lot of the actual, like, let's get this to production in Cargo and help make it actually ship. So I was more of the enabler in the middle, maybe.
The middle manager, as it were.
That's right. That's right.
So basically, this new the new way of doing things, the new hotness, is sort of an on-demand pull-based thing, where if you are, while Cargo is looking through your Cargo.toml, it will say, hey, I need regex 1.0, and it will kind of like go through and just ask for regex. And then when it gets regex, it'll say, hey, regex depends on regex syntax and aho korasic, and then it'll just get those things. And so it's much simpler. It'll end up doing more requests, HTTP requests, but it should be drastically faster, especially for anything that you do that needs to go get the index a lot, like a CI server. And then it shouldn't be any slower for your normal development. It should be probably at least a little bit faster.
Yeah, the other thing, I'll add a little bit of detail here too. Of I can't resist adding a little bit of the innards. So one interesting aspect of what Ben just mentioned is that you have this problem of, you look at the Cargo toml and it lists, let's say, 10 crates, and then each of those 10 crates might have 10 dependencies, but you won't know about those 10 dependencies until you've gone to the registry to look at what they depend on. So you send 10 requests that give you the next 100 requests to make. And it turns out that you don't actually have to do that many round trips. So it's not one round trip for every dependency. You can you branch out, you fan out the request pretty quickly. And then because we're using like HTTP pipelining and such, the requests actually end up finishing quite quickly. It doesn't get quite as bad as having to go like back and forth, back and forth, back and forth, back and forth.
And of course, it's all still cached locally, so it'll as long as the cache is maintained, it won't need to do any more work than that.
Yep.
Yeah. So that is brand new in 1.68, which is in Jon's world back in April. You still need to opt into this, but they say
that's like 6 weeks ago.
They say that in 1.70 it will become stable. So who knows? Maybe we'll see in the future whether or not that came true.
That seems unlikely. That's so far ahead of now.
Who knows? Six weeks is a long time.
The next thing in the changelog is local pin construction. And this is the, let's say, more formal name. The more informal name is stack pinning. So the idea is that if you have a future of any kind in Rust, you have to pin it before you can pull it. So you have to pin it before you're allowed to really execute the future. And pinning is a way to say the contents of this type will never move again, as in its address in memory will not change. And this is necessary to allow futures to be self-referential. which in turn matters for things like async blocks, where you might declare a variable but also have a reference to that variable inside of the same async block. So that is inherently self-referential. And the way that you get around this is you pin the future. So pinning guarantees that it will not move again. And so if you pin the future, then it's now okay for futures to be self-referential. And traditionally, the way that you pin something is you can call box : pin, and that will put it on the heap. And once it's on the heap, then it doesn't really move again. Like even if you move the variable that holds the box, the thing behind the box will not move. But of course, that means that you have to use heap memory, which sometimes you don't have access to, and sometimes you just don't want to have to go through the allocator. And so the alternative is something called stack pinning, where you have a variable, you have a future, say, on the stack, like you've declared it in a local variable in a function, and you just want to sort of guarantee that it doesn't move again until the time it's completed within the context of this function. And some of the like async crates that we have in the ecosystem, like the futures crate or the Tokyo crate, has a macro called pin that does exactly this. And the way that they work is essentially you write Tokyo : pin, and then you give the name of a local variable, and it will do some magic trickery so that the thing behind that variable is now pinned. It cannot move again. Its address cannot change. And that name, that variable name, from now on in your function refers to the pinned version of that value. So if it's a future, for example, that means that you can now execute it. The reason you often don't have to declare this yourself, if you're just like, executing futures the normal way, is usually your asynchronous executor will take care of pinning on your behalf, usually on the heap. But sometimes if you're using something like a select macro, then you might actually want to do the pinning yourself, in which case you either have to use box pin or use something like this Tokyo pin to pin on the stack. And of course, this is a pretty fundamental feature or mechanism that you need for working with futures. And so it's something that is pretty natural to want to have in the standard library. And in 168, we got now the pin macro, which takes a stack variable t and gives you back a pin mutable reference to t. So a pinned pointer to t, where the guarantee is that the address of t will not change anymore for as long as that pin lives. And indeed, for as long as that t lives. And it works very much the same as for, say, Tokyo or for the futures pin, except that the standard library has the special ability that, because the pin type is declared within the standard library, that also means that the standard library has access to private fields of the pin type. And it turns out that when that is the case, the macro can be a little bit nicer. So I mentioned how the pin that's out there in the ecosystem, you give it the name of a variable, and it will now reassign that name to be a pinned pointer to that variable instead. The one that comes from the standard library is actually nicer. You can say like, let pinned future equals pin, and then give it any value. Whereas the other one would sort of act like both a let and a consume of that name. So it's a little bit nicer to work with, and just by virtue of it being the standard library, so it has access to a little bit more of the internals that lets the implementation be less restrictive, let's say. And we'll link in the show notes to the actual like gory details here of there's a huge comment that explains why this is okay, and also how it works differently from the external ecosystem. And it's a pretty interesting thing to rabbit hole on if that's your jam.
Up next, we have the default alloc error handler. And so error handling in the case of an out-of-memory error in the standard library is a pretty interesting and long discussed topic in Rust. And so currently today in Rust, if you have, say, you allocate a vector, and you say, give me a vec full of zeros that's like the size of the sun. Give me that. It's going to abort your program. And that is pretty, there are pros and cons to this. Generally, it's pretty much okay for many applications. For some, it's not. In those cases, there are more and more these days alternative APIs being provided so that you can manually handle allocation failures and such. But by default, since 1.0, the idea is that whenever you get an out-of-memory error, it will just abort. And this is not a language thing, it's a library thing. And so this is the thing that is unique to Stud, because the language itself has no concept of allocation. And so what this new development in 1.68 is that if you aren't using Stud, So stood as a crate is comprised of some smaller crates that offer fewer features. If you want to get rid of stood and use kind of like a more fine-grained, fewer features for platforms that don't support certain things. And so there's core and there's alloc are the two constituent kind of like subsets, like profiles of stood that you can use. And nowadays, if you use core or alloc, rather than abort whenever you get an out of memory error, you will now panic instead.
And crucially, panic and unwind.
Panic and unwind, right? Well, so it should still respect your panic handling configuration strategy, right?
Yes, I believe so.
So it'll be you can configure in Rust. Panic can either unwind or abort, and so if you want an abort, it'll still do that. But if you want to unwind, it will do that too. And it seems kind of like a half dozen of one, six of the other situation, where it's kind of like, well, for a lot of the cases, aborting and panicking are kind of just the same thing. But it gives you a bit more control over things, and I think it's just the idea of removing some specific behavior that doesn't need to happen. And one of the reasons that you kind of the original impetus for aborting in the first place is that if you hit out of memory error, and then you need to guarantee that you don't try to allocate any more memory as a result of panicking. And so one way to do that is just by aborting immediately. However, that's kind of not required, because in Rust, let's say you're panicking, and then you have something that happens. Like, so you say you have a drop impulse. So panicking is going to unwind, run all your destructors on the stack, and say that you just put a panic in a drop. If you panic while you're already panicking, that's an immediate abort. So any kind of double panic like that already happens. And so you could imagine that if you just specified that out of memory error, allocation error, was just a panic instead as normal, then you would get, you could unwind as usual. And then if it happened again, then it would still abort and there wouldn't be a problem there. And I believe, as far as we can tell, our archaeology has revealed that the reason that this wasn't done is because it gives you less good of an error message if you happen to hit the double panic case in the case of out of memory error. Whereas currently, if you abort immediately, you're always guaranteed to get, hey, you're out of memory, here's what happened. Whereas in the new case, you're only going to get that nice error message if you hit the out of memory error on the first panic, and the second panic might just be a totally random error message. And I think the idea here is that because it is less likely, most of the time, whenever you get a memory error, it's probably going to be a very large allocation. And unwinding generally doesn't create very large allocations. And so it's entirely possible that even if you're out of memory, the ability to allocate small pieces of memory could still exist. And so it's probably unlikely, as far as developers here are concerned, that you will see the out of memory error, or that you will see the less good error message as a result of the double panic, as opposed to getting the nice error message as a result of the first panic that happens when you try to do allocate the size of the sun.
Yeah, and then the other thing that's nice here is that because it now panics, you also end up invoking the panic handler if you've defined one. So this lets you both work with a sort of global panic handler that's been set, but also with things like catch unwind. So you can now catch unwind to catch if something panics because it couldn't allocate enough memory, and then do something else if you catch that panic.
And also, it mentions here as well that in the future, it is likely that stood will change. So that even if you currently, it's only if you use alloc, and in the future, if you use stood, it will do the same thing.
In the list of stabilized API, we've already talked about the pin macro, and then there's an implementation of from bool for F32 and F64. Do you want to say something about this, Ben?
Right, and so now, just like you've always wanted, if you have the value true, you can say as F32 and get a 1.0. Just extremely convenient. Really, it's just because from bool as U8 and I128, all the kind of stuff, right? That already exists, and there's already from bool for U8, and there's also from U8 for F32 and F64. So it's just one of those cases of adding a transitive implementation, because who knows? Maybe someone somewhere out there is using this and doesn't really cost anything to add it.
Yep. I don't think the other stabilized APIs are too interesting for our cases, so I'll dive into some of the deeper changelog things. One of the things that I thought was neat is that in 168, the ABI EFI API feature was stabilized. And now that's a mouthful, but basically it is the calling convention that is used if you write UEFI programs. So UEFI is the sort of the very low level machine that runs when your machine first boots up. So basically the thing that starts your hardware, starts your hard drives, and then calls your bootloader is UEFI. And so now the calling convention that's used to write UEFI programs is now available in Rust. So you can write extern EFI API fn, whatever the name of the function is, which I assume matters because someone's trying to write UEFI programs with Rust. It was just neat to me that that is now a thing that you can do. Also, the cargo build command has now gained a -- verbose flag. When you pass -- verbose to cargo build, it will now tell you why it rebuilds certain crates. So if it ends up doing a rebuild of either your dependencies or your crate, it'll tell you why it did that rebuild, which can sometimes be really helpful if you discover that your crate keeps rebuilding, or you discover that one of your dependencies keeps rebuilding even though you built it before. Often it's for reasons like a build script isn't configured quite right and is a little over eager about running again. And so I just think this is a nice way to get a little bit more of an understanding for what's going on and why. In Cargo, the home crate, which defines the home directory location for both Rustup and Cargo, has now also been taken over by the Cargo team. It used to just be a separate crate that was just maintained by someone else, and now it's been sort of brought into the Cargo family of crates. And so hopefully it'll see some love going forward. And also in Cargo, and this is just sort of a caution, if you will, is that previously Cargo package and Cargo publish would not respect the lock file in a workspace, which was just entirely a bug. But that has now been fixed. So you might now suddenly see something respecting your Cargo.lock, like specifically Cargo package and Cargo publish, and just know that that's because it's more correct now. And then the last one I think I had from the detailed release notes is that is a little bit interesting. It's a backwards incompatible change in the standard library. So the context type, which is passed to futures when you poll them, used to be both send and sync. And this wasn't necessarily an intentional choice. It didn't have any fields that weren't send and sync, and so it was send and sync. But in 168, they changed that. So they explicitly made context be not send and not sync. And the reason they did this was because they think that in the future, they may want to add fields to context. Context is sort of the type that a future uses to discover the asynchronous executor that is executing it, for things like notifying it that a future should be woken up later on, for example. And so context might in the future gain fields that support, say, single-threaded executors. And those fields might be not send or not sync. And so context might become not send or not sync in the future. And so they basically made the observation that we should break this now rather than later before people start to rely on it. So they did a whole crater run and found that there basically weren't any assumptions that, or any crates that made the assumption the context was send or sync, or any that they found they fixed. And so now they've just made that breaking change in 168, and now context is not send and not sync, which means that in the future we can add not send or not sync fields to it without breaking anyone.
Well, can you also elaborate too? Because as far as I know, Tokyo has a version that is single-threaded, right? You can spin up a single-threaded Tokyo executor, can't you?
Yeah, you can. So the reason why they added this was because currently, at least in the case of Tokyo, the way that Tokyo communicates the executor to tasks is in part through thread local state within Tokyo. And so that state Tokyo can manage entirely on its own. Whereas the thinking here is that in the future, this context type, which exists in the standard library, might start to gain capabilities for things like use this thing in order to do timers, use this thing in order to do IO. That's not something the context type currently contains. And most of the existing asynchronous executors just have their own mechanism for it. But if we were to try to standardize and bring it into the standard library, chances are it would have to be exposed through context. And then for any executor that isn't thread safe, essentially, that data or that type that goes into context would also need to be allowed to not be thread safe. I think that's all I have for 168, although we have 2 point releases here. With 168, we both got 168.1 and 168.2, and they're actually not related to each other. 168.1 is just discovered that there was a miscompilation when Rust link time optimization, or the Rust LTO, was enabled when using the Windows compiler. So they basically just turned off LTO until they figured out what went wrong. And so I believe it was turned back on again for 169. So it was just like a miscompilation that someone discovered and reported, luckily. And so then they decided to do a cut a point release so that people on Windows wouldn't be blocked from using 168 or wouldn't be blocked from using it and accidentally having miscompilations just because they had LTO turned on. And the 168.2 was actually not even caused by the Rust project. So GitHub had a security incident where they ended up rotating the SSH host key for all of GitHub's hosts. And this had a lot of ramifications throughout the various ecosystems because a lot of tools will like hard code GitHub's public key to make sure that when you do, let's say, like we talked about earlier, when you do a git pull from the Rust registry index GitHub repo, you do a clone, you're actually talking to GitHub. You're not talking to some random other server that's pretending to be GitHub because there's no HTTPS here, right? It's just a Git protocol. And so the way you do that is you verify the public key of the server that you get over SSH. But when that public key changed, suddenly Cargo would think that you're not talking to a legitimate GitHub and would start erroring out. And this happened to a lot of other tools as well. And so they cut a point release that updated the bundled GitHub public key that's in Cargo, and then also registered the old key as being revoked and no longer being accepted. And so that warranted a point release as well, in part because it's a security issue, and in part because it would unblock people who were starting to see errors when Cargo was legitimately talking to GitHub. I think that brings us to 169, Ben. And this one has the best release date.
Does it? What was it?
Well, so this is the infamous Rust 169 was released on 420.
But hold on. I'm going to have to ask you to use ISO standardized dates here.
I'm sorry. The release date of Rust 169 is 2023-04-20.
Humorous. Very humorous.
And so as a result, the release date is 420 for at least most of the world. And so Rust 169 was released on 420, which is nice and funny.
Can you elaborate, though? Why is it nice and funny?
It is nice and funny because 69 is a common sexual position. And 420 is a reference to a narcotic drug.
No, John, you're totally wrong. So 69 is a reference to Gemini, okay?
I see, of course.
For those of us who are into horoscopes, well, you have kind of know, right? It's very Gemini of you to not understand how funny it is to have two fish like that.
I see.
So, I mean,
I see, yes.
Let's move along.
Very yin-yang.
This isn't the horoscope podcast.
But then why is 420 funny in this world?
Because it's kind of like if you look at turn it on its side, it kind of looks like a cow, and that's Sagittarius. I think. I don't know.
That makes sense too.
I'm a Scorpio. I'm stupid, so who knows?
I think what regardless of which of the funny interpretations is your preference, the thing that I like the most about this is that Rust has stuck to a 6-week release cadence since Rust 1.0. And so it makes you wonder whether this was planned or not.
It does seem like it was planned, but it's almost certainly just one of those weird coincidences that sometimes the universe is pretty funny like that. Cosmic joke.
I want to add in a little fun bit here, which is that there is also a Git. Let me see if I can find this one. So if you go to the Rust repo and then you look for PR number 42069. It's a pull request that adds the option to run Rust build on low priority on Windows and Unix. And if you know Unix well, you know that the way that you change a process priority is you set its nice value. And so PR 42069 adds support for nice.
Well,
I know, it's fantastic.
Incredible. How many years were they waiting to add that to Rust? Just kind of like, we can't add it just yet.
I don't know, but
it's
so good.
Number goes higher.
It's so good.
Oh my goodness. Okay. Well, it's funny because this release actually has it has a lot of work, a lot of weird stuff as we'll get into it. But like actually, in terms of user facing features, there's almost nothing. So again, there's over 3,000 commits from hundreds of contributors, but mostly it's maintenance stuff and kind of like, driving home that lots of Rust development these days is just like doing small fixes and things and quality of life stuff.
I think it depends on who you are as a user. I'm sure that there's some user out there who's like, 169 was the big release for me. Without this, it was impossible for me to use Rust, and now I can. I'm sure there's someone who felt that way.
So we'll get into the weird stuff later on, but like now the headline features are Cargo now suggests to automatically fix some warnings, and so kind of just doing a PSA here again in terms of Cargo. Cargo has a feature called Cargo Fix, where if there are certain errors that it will see in your code, it knows how to fix automatically for you. And so you may have seen Cargo Fix in the context of additions, where whenever you do an addition upgrade, you can use Cargo Fix to upgrade most things, most addition changes from the old to the new edition. Cargo Fix obviously has the power to rewrite Rust code, and so it can also do it for you in other contexts too. And so if you have like a simple problem like, oh, you don't want to have a lifetime there and like various things in a constantly growing list over time of things it can fix, you can just run Cargo Fix, and like if there's an error or a warning on your screen, in many cases it will just automatically patch your code for you. And if you're using source control, like you can obviously inspect it before you check it in or anything. And also, in fact, Cargo Fix doesn't do anything by default if you have a dirty source control tree. So it won't mess up your files. If you want to, see if you have a problem, you can just, git commit or git stash or whatever, and then run it and see what changes. So yeah, PSA, now it is recommending to be used.
Do you remember whether Cargo Fix has an allow dirty flag the same way that Cargo Publish does?
It does, yes. So you can also override that if you'd like. And so now it's being advertised more, and we're advertising it more too, because having your tools work for you is great. It's one of the best things about Rust, that it has lots of tools. But when you have lots of tools, you need help learning it, right?
It's true. This next one is, the headline here is debug information is not included in build scripts by default anymore. And this came out of some benchmarking that I think it was Nicholas Nethercott who did the sort of background work for this. And they've been doing a lot of good performance optimization work for Rust just in general. But they found that one of the reasons why Rust builds can be slow is because Cargo spends a bunch of time building, debug info, and especially for build scripts, which they sort of happen on the critical path to building any crate. Right. So in order to, let's say, compile, what's a good example of this? Well, any crate that has a build script, in order to compile that crate, if you're using it as a dependency, you first need to compile that crate's build script and then immediately run that build script and then compile the crate. And this means that if you can shorten the time it takes to build and run the build script for a crate, you're shortening the whole path, the whole time it takes before you get to building your own crate. And generating debug information for these build scripts is usually not that useful, because chances are they're not really going to panic, right? Like, they're usually fairly straightforward scripts. They maybe have error handling, but they've been used to build this crate for forever. And so they don't change very much, and they're relatively unlikely to panic. And so as a result, they made the choice to make Cargo no longer emit debug information when building these build scripts, which speeds up their build by a decent amount, especially because they tend to be fairly small code-wise. So the debug information generation was a decent proportion of the build time. And so now it's just all builds are a little bit faster, but the backtraces, if the build script panics, are a little bit worse. What I'll add, though, is there is a mechanism to get back the old behavior. Like, if you discover that a build script keeps panicking and you want, say, a more useful backtrace about how it got to that panic, you can set a little snippet in your Cargo toml that's also included in the release notes to specifically say, I want debug information even for my build scripts. And then Cargo will respect that.
You mentioned Nicholas Nethercott. I'm not sure if he was the one who did this or not, but he definitely has done a lot of really good work. Many folks have, actually. And so we're going to, in the show notes, link to his blog, where he has lots of great write-ups on like the nitty-gritty of what he gets up to whenever he tries to benchmark and optimize, and what works and what doesn't. And they're great reading. And kind of just like the general summary in his most recent one, he had from the period, again, ISO 2023-03-22 to 2023-08-24. The basic rundown is that time used to compile, wall time that is, reduced by 7.13%.
Nice.
Peak memory usage reduced by 10.53%, and then binary size reduced by 2.65%. And I'm pretty sure that in the speed testing harness, that's testing their normal, testing a kind of a suite of standardized benchmarks that they have collected. And that probably doesn't include things like build script debug time or things like the Cargo sparse registry stuff. And so that's all gravy on top of, this is all just like pure compiler performance.
And so ultimately you end up with gravy on top of gravy on top of gravy.
You got a gravy sundae in there. Yeah,
that's right.
It's like a 3-layer gravy cake.
Nice.
It's pretty good. You should try it sometime. Don't knock it.
I don't know. I'm skeptical. We have one stabilized API here. There's some const stuff around socket data that I don't think we need to go too deep into. But this stabilized API around C-string from bytes until null. Do you know much about this, Ben?
No, I don't.
So I've worked a little bit with C-string. So C-stir and C-string are the Rust equivalent of C strings, as the name implies. So in C, strings are sequences of characters terminated with a null byte. So the way that C represents strings is not the same as in Rust. So in Rust, a string is a UTF-8 encoded byte string, but you also store the length. It is basically a U8 slice. And slices, you have a pointer to the start and you know the length, you know the number of bytes. For a C string, you'd never store the length of the string. You only ever keep a pointer to the start. And the way that you figure out how long a string is you walk it until you find a null byte. Now, the Rust C string type has a constructor that, well, it has multiple constructors. One of them just takes a Rust stir. One of them takes a byte slice and then checks that there's a null at the end and there are no nulls in the middle to make sure that this is like a valid C string. But now there's a new constructor that's been added to C-stir, which is from bytes until null. So this is, you give it a byte slice, and it will find the first null character in that byte slice, and then return a C-stir that has a pointer to the beginning of that subset of the byte slice and knows where the null byte is in that C-stir. And because the null byte is at the end, and we know there's none in the middle because this is the first one we found, it must be a valid C string. And so this can be useful whenever you're interfacing with C APIs, or if you're doing things like parsing byte input that has been serialized by C. And so you just want to find, like, you know that the next thing in the input is a C encoded string, then you can use this to get a handle to just that C encoded string.
And what's new here is not the method itself, but the fact that it is now const.
No, this is actually the method is new.
Okay.
So the constifications are a lot of the constructors on socket data, but this method on C-stir is actually new.
Well, it's also const.
It is also const. It is new and const from the beginning. Maybe this is what we're going to see in the future, is that we aren't really going to see constifications anymore. Everything is just going to be const from the get-go.
That would be the ideal.
In the detailed change notes, there are a couple of interesting bits. One of the ones that is actually fairly important is that there's a lint called unaligned references that I think we've talked about maybe in Rust 162.
I think 53 as well. We might have talked about this.
Yeah, 53 is when it became worn by default, and 62 is when it started to be brought up in future incompatible reports. Now, for 168, the unaligned references lint is now a hard error. And the unaligned references lint is just saying that if you have a packed struct, so one where there's no padding in between the fields, trying to take a reference to a field that isn't aligned according to the alignment rules of that type is now a hard error, because like a bunch of CPUs just will refuse to do that or will just not work correctly if you try to do it. And so the compiler will prevent you from doing it. And this is, interesting in and of itself. If you're doing this, you've been getting a warning for a while, and now finally you get a hard error. But it has some knock-on effects. So one of the interesting ones that I found was that if you derive a trait for a packed type, like imagine you're deriving debug, say, the expansion of derived debug is essentially, the compiler effectively has a macro, right? So it walks all the fields of the struct, and for each field of the struct, it prints the name of the field, and then it prints the result of calling the debug format method on each field. So it generates field, and then the debug value of that field, and then field, and debug value of that field. But if you think about it, that doesn't really work if you have a type that is packed, because implicitly in there, the compiler is taking a reference to each of the fields. So if one of the fields is unaligned, then now the compiler is breaking its own rules. And previously, the behavior here was that if a struct was packed and implemented copy, then it would copy the field out before calling the inner method or doing whatever it wanted to it. So copy the field out and then take a reference to it. Because when you copy the field out, like you do let x equals and then like self.0, for example, then now you're moving the value out, which is fine. You're not taking a reference. And the value you've stored it into, like this x value, is aligned because it is only of type T. So it's no longer inside of a packed struct. And so now you're allowed to take references to it and do whatever you want. So all of this derived code needed to know whether the field they're referencing is inside a packed struct or not and know to pull this trick. But it would only pull this trick if the struct itself implemented copy. And then there was sort of a last condition, which was if the type does not implement copy but is packed, then it would just like try to take a reference to all the fields. And if it happened to work, then it was fine. And if it didn't work, then it would complain to you saying these fields aren't aligned. What's changed in 169 is that now there's no longer this requirement that the type has to implement copy. There's no longer this like, if it happens to be aligned, then it's okay. Instead, now the requirement is just that all of the fields of a packed struct implement copy. If all of the fields of a type implements copy, then you can derive traits on it, even if it's a packed struct. And so this is generally going to be easier to work with. And then the main thing it breaks is there are a very small number of cases where you accidentally all of your fields were aligned, in which case you didn't need packed in the first place, where you're now losing the sort of thing that used to work but now doesn't. But on the whole, this is going to let people derive traits for many more types.
And more than just the packed thing, I think, most folks are not out here using the packed representation, but I think it's kind of just illustrates the approach that Rust takes towards compatibility and soundness, where Rubber Packed is like a 1.0 feature, I'm pretty sure. I mean, if not 1.0, then like soon thereafter. And so like there for a long time, but it was kind of unclear how unsoundness in this would manifest, right? Because as Rust normal philosophy would go, you would like want to like wrap every single deref in like, an unsafe block, because what if that pointer is unaligned, right? And so in this case, it's like, well, we should just prevent, well, in the first place too, it is also later clarify that it is undefined behavior to even have a reference that is unaligned in the first place. To even like construct them is immediate undefined behavior. And do you happen to know why that is? What is the problem that you can't, like, they can't even be made to work?
So, as far as I understand it, at least, Rust declares to LVM that all references are aligned to their underlying type. And then LVM makes optimizations based on that assumption. So imagine, for example, that you have a reference to a type that is fairly large or has a large alignment. Then, at least in theory, LVM knows that the lowest bits are all 0. And if it knows that the lowest bits are 0, it could make the optimization to use those bits for something else. Things like if you put this thing in an option or inside of an option or something, maybe it can use those bits in a sane way. I don't know of any such optimization, but it would be totally legal for LLVM to implement such an optimization, which would then break anyone who violated that assumption by creating a reference to an unaligned field.
Well, you mentioned putting that attribute on references, but if you look at the Rust reference in the Nomicon, it is undefined behavior to even deref a raw pointer that's unaligned.
So that, I believe, is for a different reason. I believe that is because there are a bunch of CPU instructions that require the input to be aligned. And so depending on what that dereference does, it may or may not be legal for the relevant CPU instruction. So I think that's probably why they've declared that as being unsound.
Okay, so those are different things entirely then.
I think so. I'm not 100% sure, but I think those are different.
Anyway, so the underlying point is that this future compatibility warning is a way of how Rust gradually over time fixes soundness errors, where it's like, hey, in our Rust 1.0 future-proof guarantee, we have so-and-so guarantees in terms of like, what can break, what are we allowed to break? And one of the things that's allowed to break is soundness. But just because things can break in order to make code, sound safe, doesn't mean that they are eager to do it recklessly, where, it took over, 15 releases for this to go from a warning to a hard error.
Yeah, and I think part of this is also like you do a crater run, so you build like every version of every crate ever released. You check for regressions, you work with the authors to improve the ones that did break. And like there's also the recognition that there's a bunch of private code that's not on crates.io that might also break as a result of this. So they sort of use the crater run as a litmus test for what problems might arise elsewhere. It's not perfect, but I think they do move quite carefully if they decide that breaking is actually the right call here. I had a couple of other smaller ones that are more in the sort of tooling ecosystem. One of them is in Cargo. So it is now the case that if you run cargo install on a crate that is a library, not a binary, then Cargo will now tell you use cargo add instead, which I think is just small little quality of life improvement, right? Where people who might not know about cargo add or not really be sure about the distinction between cargo install and cargo add, it feels kind of natural to just run install when you want a thing. Now Cargo will sort of nudge you in the right direction. And I like this general inkling in Rust to like nudge people in the right direction where you can. And I think this is a good example of that. And then the other one is an improvement to RustDoc. So in RustDoc, if you now in the search field put an exclamation mark at the end of your search, it will now actually search for macros. So in the past, if you put an exclamation mark at the end, it would just kind of be ignored. Like it would still search for things that weren't macros, but now that actually indicates the macro search. So this is just like, if you ever used this in the past and you were like, why am I getting non-macros? That's now been fixed. And I think the last thing I wanted to mention for 169 is there are a decent number of backwards compatibility notes. So these are things where something changed in Rust that is not usually it's not a breaking change necessarily, but just something that if you use Rust in particular ways, you should be aware of. So one of these is that the minimum external LLVM that Rust requires is now version 14. So you can no longer build Rust using your own LLVM if that LLVM is older than LLVM 14. That's an example of this kind of compatibility that might or might not affect you. There are a couple of other ones that are interesting around how Cargo workspace dependencies work with default features, and about the ENV, so the environment variable configuration table for Cargo, where you can no longer set Cargo home. So there are a couple of these that might be interesting to look at just if you're using Cargo in weird ways or using Rust in weird ways or building Rust in weird ways. Those are always worth taking a look at whenever a new Rust release comes out. And I think that's all we have for this week, Ben. Makes me sad.
I did want
Yeah.
to. I wanted to note one final thing, which is just that this detailed release notes file that Jon is so fond of. Every single podcast has to go in there and dig around, root around for the secrets that they don't want you to see. If you go in here, so we'll leave a link to it in the release notes. It's just in the main Rust repo. It's just releases.md right there in the root, and it's been going back all the way back to version 0.1, released 2012-01-20, and as of this release, it is now so large that GitHub has a hard time rendering it, and they might have made some changes, but back when this came out, GitHub failed to render this file because it's so long and there's so many changes to Rust over the past 11 years that it just breaks GitHub's Markdown renderer.
The file is 0.5 megabyte large. It's a text file.
I want to just like read. I scroll down all the way to version 0.1. Let's read the headline features. Most language features work, including unique pointers, unique closures, move semantics, generics, static interface dispatch,
Nice.
stack growth, aged poorly, multi-thread task scheduling, tasks, type state predicates, failure unwinding, destructors, pattern matching. It's a pretty good one. I'm a big fan of that one. Lightweight block lambda syntax. I've totally forgotten what that even is. And preliminary macro by example.
I think my favorite is under known issues for version 0.1 is documentation is incomplete and performance is below the intended target.
Well, that's the problem. Is like, no matter in every project, is there ever a time when documentation is complete or performance is above the target?
Definitely not. That's great.
We should, as a matter of course, every release, just add those in there.
Yeah, documentation is still incomplete and performance is still below the intended target.
The docs are good, but they could be better.
Yeah, that's right. And it's fast, but not fast enough.
We demand better.
I think we even made it in under the 1 hour mark, Ben. Good job, us.
We did. So we got two of our backlog in the shovel. I anticipate that you will continue to travel at the speed of light at or near. And so we will reconvene.
I was going to say, the thing that makes me sad now is I have to wait 12 weeks until we do this again, but you only have to wait probably like a couple of days or something.
Yeah. I'm not sure if that means I'm moving faster or you moving faster. I think in this case, I'm the one who's moving. So I hope you bought me a ticket to the spaceship.
I'm never moving fast, so it's definitely you.
All right, great. Well, I'm going to go board this spaceship. Do you happen to have a spaceship liftoff in that soundboard?
I have like a horse and cart.
Okay, well, this could be one of those. It's kind of like, Back to the Future 3, where he...
Let's see, what can I find? The closest thing I have to a spaceship is...
That's the end. You only have like that. That's all you have.
Well, no, I also have this one. So I don't know which one is your spaceship taking off, but you gotta pick one of them.
Well, one of those sounds like a very comical explosion, possibly.
Yeah, I feel like you don't want either of these to be the sound of your spaceship taking off.
Like the Looney Tunes, this rocket just falls over like plop.
That's right.
So that's where I'm at right now, trapped inside this rocket, and I'll see you in a little bit. Our dear viewers, viewing your podcast bar.
Yeah, we can call them. They're probably looking at their screen right now going, what is Jon and Ben talking about?
In disbelief, like,
That's
what
right.
on earth are they even looking for a new podcast to listen to? They're like,
no, they're
I'm
actually
tired.
scrolling through the releases page.
For the unsubscribe button.
That's right. All right, we will chat to you next time. And until then, keep reading the release notes. There'll be a test at the end.
At the end of Rust history, there will be a test.
That's right.
All right. See ya.
See y'all.